So now that we've gotten our quadrilateral all drawn out, we need to actually start trying to solve this. So what we're going to do is we're going to find the area of this entire quadrilateral. Now this is not a regular quadrilateral, it's not a square, it's not a rectangle, it's nothing that's regular, right? The sides are not the same, the angles are not the same, so we can't just use a formula for regular polygons. Instead, what we're going to do is we're going to create triangles within this shape and solve each triangle separately and then put together all of our answers. All right, so first thing I'm going to do is I'm going to label this quadrilateral so that as we're talking about different angles or sides, it's going to be easier to know which ones. So I'm just going to call this A, B, C, D, right? So point A, point B, point C, and point, you can see it, point D. All right, so the first thing that we need to think about is, well, how are we going to split this quadrilateral up into a triangle? And there's two different ways that we could do that. One way is that we could kind of cut it right down the middle, right? And we wouldn't necessarily have two triangles that are the same, but we would have two triangles. And then the other option would be to cut it across this way. All right, and that's what I'm going to recommend, and here's why. We already have a lot of information right here in this area, and so I know that there's an area formula that is for SAS triangles, right? Side, angle, side, triangles. So it's going to be really easy to find the area right away. So what I'm going to do is I'm going to cut this triangle in two, and I'm just going to use the dashed line to show how I'm cutting this quadrilateral up into a triangle. So now I have triangle 1, and I'm going to call this triangle 2. All right. So if I could, I would just use my formula for SAS triangles and plug right in. But the only thing is I'm actually missing some information about this angle. Only this little piece is 50 degrees. I still need to figure out what this piece equals, and then I have the entire angle. So we're going to use some geometry rules. We're going to use alternate interior angles here, right? I have a parallel line here, I have a parallel line here, and this is my transversal, this side. So I know that this angle and this angle must be congruent. So I can accurately assume that that is 21 degrees. And that means that the entire angle is 71 degrees, right? 50 plus 21. So now I can go ahead and find the area of triangle 1. Okay? And I'm going to use the formula that uses sine. So 1/2 times BC times sine of A. Alright, let me make sure I wrote that down correctly. Yes. Okay, so we have 1/2 times, I want these two sides, right? This is the included angle, that's going to be A. Yeah, you know what, actually, I should have, these are not, that's not the correct sides that, as far as how I've labeled, but we can use the same idea, right? I know that my angle is going to be the included angle, and I know that the other two sides have to be the adjacent sides. So I'm going to do 1/2 times 590 times 780 times sine of angle A, which is 71 degrees. All right, so I can go ahead and plug that in. So I'm going to do 0.5 times 590 times 780 times sine of 71 degrees. Make sure your calculator is in degree mode. All right, and I have an area of 217,563.8242, and that's going to be meters squared. Alright, so I have the area for this entire triangle right here. The next thing I need to do is find the area of the second triangle. However, we're not completely done with the first triangle because we're going to have to use all this given information to find other things about this triangle that will help us solve the second triangle. Alright, so the next thing that I want to do is I want to actually find this side length right here because I have no side information about sides for triangle 2. So this is a side that triangle 1 and 2 share. So whatever I find for triangle 1 here will obviously apply to triangle 2 because this side is the same. So what I'm going to do is I'm going to go ahead and use one of the law of cosines formulas, and I'm going to find this line segment right here. So line segment AC. All right. So I'm going to find the length of AC. Okay. So let's go ahead and take a look. So I know that if I want to find that side length, I'm going to call that B, right? Side B, because it's across angle B. So B squared equals, and if we take a look at the law of cosine formulas, we know that that's going to be A squared plus C squared minus 2AC times cosine of B. Alright, so side A is this one right here, so we have 590 squared. Side C is 780 minus 2 times those two sides again, just not squared this time, times cosine of angle B, which is 71 degrees. Alright, so let's go ahead and plug that in. I'm going to save all this information. Don't clear any of it because at the very end it's going to be really useful to have this. So I'm going to do 590 squared, 590 squared plus 780 squared minus 2 times 590 times 780 times cosine of 71. So do that all in one line. Don't split up the different parts. And we get this huge number, but remember that that's B squared, so I need to square root that value. Alright, so I get side B is approximately 810.5 meters. Alright, so that's what we have here, 810.5 meters, and that's approximate, and unfortunately in a problem like this, we're not going to be able to avoid rounded answers. Alright, next thing I want to do, I'm going to eventually need some kind of an angle in triangle 2. So what I'm going to do, this is just preference, I'm going to go ahead and find this angle right here, and that's going to help me find this angle in triangle 2. You could also do the same with this angle, right? If you find this angle, you'll have enough information to find this angle using all the geometry rules. So it's just my personal preference. I'm going to go ahead and find angle A in triangle 1. Alright, so the way to do that, angle A in triangle 1, alright, is I'm going to use law of sines. Okay, so I have a complete set right here. I have angle B and side B. Alright, so I want to find angle A. So I'm going to do sine of A all over side A. So that's going to be across 590 is equal to, and then I'm going to use my complete set. So sine of B, which is 71 degrees, all over 810.5. Alright, so to solve for A, I'm going to multiply both sides by 590. So I'm going to have sine of A. Let's go ahead and take a look. So I'm going to plug in this fraction first. I'm going to do sine of 71 degrees divided by 810. Now, if you wanted to be super accurate, you could just use this value. I'm just going to go ahead and use the rounded value, 810.5. And then my next step would have been to multiply by 590. Alright, so I have sine of A is 0.6882 and so on. And I'm going to go ahead and do sine inverse so that I can find just angle A. So I'm going to do second sine inverse of this value. And I have 43.5 degrees. Alright, now you have to remember that sine also could technically have an angle in quadrant 2, and that would be 180 minus this. But if you do 180 minus that and you have another angle of 71 degrees, it's just not going to work out for you. So I'm going to take the acute angle here. So this is going to be 43.5 degrees. So that's this little angle right here, 43.5 degrees. All right, now we're going to use a lot of geometry here. We got to remember that this right here is a straight angle. So all the way around, this is 180 degrees. So I have this piece of an angle, this piece of an angle, and this piece of an angle. I only don't have this, which is the complete angle in quadrant 2. So what I'm going to do to find that is I'm going to do 180 minus all of the other pieces. So I'm going to subtract 21 degrees. I'm going to subtract 43.5 degrees. I'm going to subtract 10 degrees. And that's going to give me 105.5 degrees for this angle in triangle 2. Alright, so remember that is a straight angle, 180 degrees total. Right. Now, the only thing I need left, if you notice what we have so far, I have a side, I have an angle. If I could just have this side of triangle 2, I can once again use my side angle side formula and figure out what that's going to be. So let's go ahead and do that. Let's find this side right here. Okay. So I'm going to go ahead and find that's side C in triangle 2. All right. Now to do that, I'm going to go ahead and let's see, what can we do? We almost have a complete set right here. So I know this angle right here actually. This is 12 degrees, so this has to be 12 degrees as well. So this whole angle is 22 degrees. All right. So that means that I can figure out what this angle is. I know in a triangle there's 180 degrees, so I'm going to subtract 105.5. I'm going to subtract 22, right? I'm subtracting these two angles, and I get 52.5 here. Alright, so if I want to find this side, I can use the corresponding angle. We're going to use law of sines again. Alright, so I'm going to find side C. So I have C over sine of C, angle C, which is 52.5 degrees, is equal to 810.5 over sine of 22 degrees. And to solve for C, I will just multiply by sine of 52.5. So I'm going to go ahead and plug in this fraction first, 810.5 divided by sine of 22, and then multiply by sine of 52.5. And that's going to give me for side C 1,116.5 meters. So that's what I have here. Alright, next thing I want to do, I'm running out of space here, but I'm going to go ahead and finally find the area of triangle 2. So I'm going to do 1/2 times these two sides and then sine of that included angle. So 810.5 times 1,716.5, and then sine of 105.5 degrees. So let's go ahead and plug that in. 0.5 times 810.5 times 1716.5 times sine of 105.5. A lot of 5s there. And we get 670,312.5455. Alright, so now I have the area of triangle 1, triangle 2. I just add up those two areas that I found. Right? In the very beginning we had this area, and then we found this area. If we add them up, we get 887,876.4 meters squared. And that is the area of the entire quadrilateral. And we did it all by solving the triangles that were hidden inside of that quadrilateral.